Hello there. In this video, I will show you how to um, use the R to do the hypothesis testing for two proportions. Um, and the problem, it looked like this. So our freshman psychology major just as likely to change the major before they graduate compared to freshman business majors. So that is when we can compare the two population, the psychology student with psychology major and student with the business major. So in this case, we will use the Z test, okay? Z test for difference between two population proportion. Yeah, so you can use that one right here. And so if let's say the first group psychology student, that would be group number 1, and business student would be number 2. So then this case over here, we will say just likely, that means equal, right? Then opposite would equal be not equal to. So we're going to choose over here, we're going to choose proportion. So choose P and HO always equal, and then P2. And then H1 would be P1, and this one would be opposite would equal, because we say likely, that means the same, right? Then this one would be opposite would be not equal. So we have here would be P2. So do test statistics. So we're going to go over here. We're going to do Z test for two proportion. Right here, you see. Click on this one. And then here we're going to go for two tails, right? So we have it here. So we copy the code from here. So notice that the code is, it can be this one right here, okay? Copy this whole code from here to here. So I can do two here to tell. So I have it right here. Paste it in here. And what I do, X1, X2, that means the successes of each group, right? So for the first group I have, that would be 404. And then the second group would be 490. Yeah. And then the N1 and 2, that means the sample size of each group. So I have over here that would be 600 for the first group, psychology student, and the other one is 759. Yeah. So I have that one, and this one would be two-sided. So if you have less than, then you're going to choose if less than, so you choose right here less, and then if you have like more than, then you choose greater. So that's the only thing. So copy the code and follow from here. So when you done this one, it will give you the p-value, like you see right here. Yeah, so you have the chi-square degree freedom p-value right here. So this is what you're going to put into the p-value in right here. Yeah, the p-value. Yeah. Now we do over here, we do the Z test, right? So test statistics here would be Z. Yeah. And then you had to find the Z value right here. So it had the notes right here, you said. So to get the Z value right here, so the Z value would be equal to square root of chi-square right here. So the x square that we have right here. So copy this one, take square root. But you have to look at more carefully. They say here, would be positive is the confidence integral is, the confidence interval would be greater than 0. This is confidence interval right here. So these two positive. So you're going to choose that one. But if you see this one negative, then your answer over here to be negative. Yeah. So in this case over here, I'm going to put over here, I can put that my Z would be equal to just SQRT, that means square root. Yeah. And then you're going to copy this x squared right here. That means I square that you have right here. Copy this and you paste over here. Then you will have your Z value. So I do evaluate, so I will have that number in here. Yeah, so I copy this one right here. So I have it. So that's a test statistics that you have in here. Okay. Now we're going to use the p-value right here to determine whether we reject or fail to reject the HO. So remember over here, so we have this one would be our alpha over here 0.01, right? So this number is 0.2, so it's greater than 0.01, so therefore greater, so therefore we fail to reject the null hypothesis, right? So that means we keep this one. We say P1 equal to P2. So therefore over here, so that's our claim, right? Because our claim, we say likely, that means the same. So therefore, in this case, we would be statistically significant that sufficient evidence to conclude that population proportion, okay? Like this one, it doesn't work because it talk about the 600 freshmen. No, we test for the population. So you're gonna choose this one right here. Okay, so the population proportion of freshman psychology major who change major A or not, this is different, so we don't do that either. So we're gonna do, the statistically insignificant that, so this one is, so there is statistically significant evidence to conclude that the population of the proportion of freshman psychology major who are change major is the same, but they say insignificant. So we want to say would be this one here. We like to show this one. So we're gonna choose this one. Okay, so submit. I should have all correct answer. Yeah. So that's how you do the z-test. So be careful when you choose this part right here. Okay. I hope it helped.